All right, so we are going to look at doing some review, finding slope with our slope formula, and graphing equations of lines. This is going to be some material that will help us later on in this first unit. So, if we have 2 points on some line, let's call those 2 points x1, y1, and x2, y2. So we have 2 points on a line, x1, y1, x2, y2. We can find the slope with our slope formula. Some of you might remember this. We use a lowercase m to represent slope, and we take y2 minus y1 over x2 minus x1. So we subtract our two y values, and then we put that over the difference of our two x values. We have a couple of examples to look at. Let's do the first one together. And just to kind of get us started back into this, let's go ahead and label our first ordered pair x1, y1 and our second ordered pair x2, y2. And that's just going to help us eliminate any silly mistakes of plugging numbers in the wrong place. So if we follow our formula, we are going to take the value of y2 minus y1. So let's start with m equals, my value of y2 is 4. So I'll take 4 minus, then we just need to be careful here because we're taking minus a negative number. So 4 minus negative 2. And then we're going to go and we're going to take the difference of our x values. Make sure that we go back to x2, which is 1, subtract again a negative 2. All right, guys, minus a negative is really a positive. So let's switch those. And then we're going to simplify. So we have 4 plus 2, which is 6. And then in the denominator, 1 plus 2 is 3. So our slope ends up being 2. If you prefer 2 over 1, that's fine as well. Either one is totally acceptable. All right, I'm going to give you about 2 or 3 minutes. I want you guys to, oh, I totally forgot one thing. You're going to hate this, because I always did as a student. Take a couple of minutes. I want you to go around your table. I want you to introduce yourself. I will ask you every single class period to work with the people that you're sitting with. So we really need to make sure that we know each other and get comfortable, working together and helping each other. Okay, so take a couple minutes, introduce yourselves, say your names, and then I want you to work on the next example. Okay, go.
All right, my name is Seawood. Yeah, this drop-off thing. I'm supposed to slip for everything that I wanted. So I just filled that out down there. It was fine because you had everything.
Yeah.
On it, and I just leave it there. She said I get back to light at the end of this class for 5 next months.
I have Sydney or Shelby next block. So
Okay, right.
Yeah.
Shelby Johnson.
Yeah.
Okay.
So I can probably have her just out.
Okay, yeah.
I literally will.
Okay.
But take that out, maybe.
It's like, okay.
Because my prep Looking pretty good here. Oh gosh. Okay, AJ, I'm gonna pick on you today because you and Marissa are the only two names I know right now, except for Maya and Maya, but I'm not sure who's Maya and Maya. Two of you are. Okay, AJ, tell me what numbers you plugged in here to find the slope. Okay. Okay, so it's really 3 minus a negative 3, and then you change that to a positive. Good. And then how did you simplify? Very good. Negative 1/3. Okay, awesome. All right, we are going to look at the two main forms of a linear equation that we are going to use in this class. The one that you guys are most familiar with, that you use most of the time in Algebra 1, is slope-intercept form. That's our y equals mx plus b, where m stands for our slope and b stands for our y-intercept. Somebody remind me what that y-intercept is. Tell me your name. Brayden. What's a y-intercept?
Where the x and y axis meet.
No, that's the origin. That's the origin. It's okay. Remind me of your name.
Heather,
Heather.
it's the part of the line that goes through the y-axis.
Exactly. It's where the line goes through the y-axis. I love that you guys are participating so well on day 1. It makes me happy. All right, so if we are given an equation in slope-intercept form, we're going to go ahead and jump down to the first example. We have y equals negative 2/3 x plus 3. So first of all, we can identify that our slope is negative 2/3 and our y-intercept is 3. When we go to graph this, the first thing that we are going to do is plot the y-intercept. So like Heather reminded us, the y-intercept is where the line crosses the y-axis. So we're going to take that value of 3 and we're going to plot a point on the y-axis. From there, we are going to use the slope to be able to plot some more points that are on our line. Now, let's also remember, I know up here at the beginning we used the slope formula, but the other thing that we kind of talked with slope is that it is rise over run. And that's the idea that we'll use in order to plot some points using that slope. So starting at our y-intercept, how can I use this slope of negative 2/3 to get some additional points? Tell me your name. Hunter. Okay. Always go to the right. Yeah. So we're going to put that negative with the 2. So like Hunter said, we're going to go down 2 units, but then we're always going to run to the right. We can use that slope again, so go down 2 units over 1, 2, 3, plot a point. If you want, there are some straight edges in your boxes. Those boxes are just stuff for you guys to use. Please don't take it, but use while you're in the class. So if you want a straight edge, you can grab one of those to draw in your line. What questions do we have? All right, let's jump back up real quick. The other form of our linear equation that you will see, and we're going to use this later on this unit quite a bit, is standard form, and this is ax plus by equals c. Where those values of a, b, and c are constants, meaning they're numbers. So if you look down at the second example, this is an example of an equation in standard form. You can see you have your x term, then your y term, and then just the constant, the number by itself, okay? The first thing that we are going to do with this is we are going to just practice rewriting this in slope-intercept form, meaning we want y by itself. I have no idea.
I'm gonna go see whenever you get a chance to.
Okay, just put it right here. Okay. All right, so when we are looking at this, our goal is to get that y term by itself. The first thing that we need to move to the other side of the equal sign is that 3x. So we are going to do that by subtracting. Once we do that, we are left with negative 5y. Then we bring down our equal sign. Now we have a 15 and a negative 3x. These are not like terms, so we are just going to write negative 3x plus 15. We're getting there, but we still don't have y completely by itself. What can we do from here to make that happen? Carson, right? Awesome. We're going to divide everything by negative 5. So then we have y by itself. We're going to bring down that equal sign. And then I have a negative 3 over a negative 5. I can make that really a positive 3/5. And then 15 over negative 5 is negative 3. Go ahead now, take a minute on your own with your group. Always check your answers with your group. Go ahead and graph that. Okay? Go ahead and graph that. All right, Marissa, what'd you do first to graph? Okay, so we plot our y-intercept at negative 3, then what? perfect. Up 3 over 5. If you want to use that again, you can, but 2 points is really all you need for a line. What questions can I answer? Good? Okay, go ahead and flip it over. So, who was it? Hunter? No, Heather. Heather reminded us a little bit ago what a y-intercept is. So thinking about that, how would we define an x-intercept? AJ? Exactly. So when we're talking about x and y intercepts, this is where our line crosses the x and y axes. So let's say we have a line that hits 6 on the y-axis and -4 on the x-axis. Again, where that line crosses the y-axis, this is our y-intercept. We would say that y equals 6 here. And where that line crosses the x-axis is our x-intercept. And we would say that x equals -4. Now let me ask you this. Let's look at this point. That's the y-intercept. So we know that the y value of that point is 6. What's the x value of that point? 0. What's the x coordinate of any y-intercept? 0. Okay, now kind of flip around. Look at the x-intercept. What are the y values of all of these points? 0. Okay, so keep that in mind. We're going to use that idea in order to actually find x and y intercepts given an equation. Okay, notice that this is in standard form. When we go to find, let's say, the x-intercept, so again, the x-intercept has a y value of 0. So what we are going to do to find the x-intercept is we are going to plug in 0 for y. And what that essentially does, what's anything times 0? 0. That whole term basically cancels out. So I'm left with just 2x equals 6. And then that's a tiny little one-step equation that we can solve to get our x-intercept. So we can take that x-intercept, we can plot that point on our x-axis, and then we can do a similar thing to find the y-intercept. So again, what do I know about any y-intercept? Every y-intercept has what in common? The x is 0, exactly. So we're going to do a similar thing, but this time we're going to plug 0 in for x. Bless you. So this time, It's the other term that essentially goes away. We have negative 3y equals 6. So when we divide, y is equal to negative 2. That is our y-intercept. We can plot that y-intercept. And then because we only need 2 points to draw a line, we can use those intercepts to draw our line in. Questions? Okay, you guys have one to try with your group. For this one, I know you get 10 over 4 for, I forget if it's the x and y intercept, but decimals are fine for this. So you can write that as, hello. It's okay. What's up? Just 3 of them. That's okay. Well, there were like 3 like note outlines that I wanted on the salmon, and then everything else can be white. Okay. Okay. Oh, that's fine. Okay. I'll go steal some from the mailroom. So that's fine. Okay. Okay. Okay, thanks. Oh, okay. Okay, it's looking pretty good. So our x-intercept should have been 2.5. Our y-intercept 2. So make sure that that is what you had. I didn't see really any mistakes at the papers I looked at. So our x-intercept we can plot at 2.5. Our y-intercept at 2, and then draw your line. All right, the very last little thing are the kind of special cases that we have with linear equations, our horizontal and vertical lines. If you look at y equals negative 4, notice that there is no x term here. If it's just y equals, this is a horizontal line. And the slope of a horizontal line is 0. The slope of a horizontal line is 0. So the way that we graph this is on the y-axis, we go to negative 4, plot that point, and then through that point, we graph the horizontal line. you look at that last example then, so we still have that -4, but this time it's just x equals -4. There is no y term. This is a vertical line if it's just x equals. A vertical line has a slope that we say is undefined. Undefined. Kind of in a similar way as we graphed the last one here, we go on the x-axis and plot a point at -4, and then we draw in our vertical line through that point.